Now we will start two experiments which confirmed the charge and mass of electrons. Earlier we had studied about the cathode ray experiment which confirmed the existence of electrons in atoms, that is certain negatively charged particles in atoms which in the presence of electric field moved towards the cathode, that is they acted as negatively charged particles. One more thing about the cathode ray experiment is, this experiment or the concept behind cathode ray found some very interesting applications. I am not sure how many of you have seen old television sets, but old television sets had something called the picture tube. In a picture tube, an electron beam passes from an electron source and it hits the television screen, which was coated with some fluorescent or phosphorescent substances. So, when the electron beam hit the screen, they formed bright images. So, for knowing different properties of electrons, we need to know its mass and charge. So, we will study the next two experiments now. The first experiment was carried out by J.J. Thomson. It was a variation of the cathode ray experiment only. He had modified the cathode ray experiment with electric field and magnetic field. Previously, we had seen these three formulas. Now we will see their application. In this experiment, the experimental setup was something like this. There was one anode, and one cathode. And there were some gas which liberated electrons. Here the modification that was done is they put two plates which created electric field. One was positively charged and one was negatively charged. Thomson also put magnets in this setup. So, first of all, if we assume that the electric field and magnetic field are not present, so what will happen? This is the cathode. Electron beams will come out from the cathode and they will hit the screen in a straight line. As we had studied from the cathode ray experiment, that in absence of electric field and magnetic field, electrons travel in a straight line. So, in absence of these two fields, the electron beam will come in a straight line and suppose it will hit this spot A. Now, if electric field is present only, then the electrons are negatively charged, so they will be attracted towards the positive plate. So, there will be a deflection in their path and the electrons will hit this position. We can call it B. Now if only the magnetic field is present, it will come in the opposite direction and hit the point C. In this experiment, the electric field and magnetic field were adjusted in such a way that the electric force Fe and the magnetic force Fm were equal. From this setup, we will come to know about the charge to mass ratio of the electron. We will see its derivation now. Like this is the screen and this was the original source of the electron. In a straight line, it will hit this position A. So we can call this distance, that is between the screen and the electron source, as x, and in presence of electric field it will deflect to this position. We can call this distance as y. So we can write this from the laws of physics. Y equal to ut plus half of at square. Now the initial velocity was 0. So y equal to 0 plus half of at square. Now the electric force F equal to ma, that is the mass of the electron, and acceleration of the electron. We know that Fe equal to charge of electron into the electric field. Therefore, E, capital E, equal to m and a. So we get the value of a here. A is equal to this. So if we put the value of a in this, we get now this is the total distance covered by the electron from the source to the point A. This distance is x. So x equal to v into t, where v is the velocity of the electron. So t equal to x by v. Now we had seen that magnetic force Fm equal to BQV. What was B? B was the magnetic field strength. Q was the charge. Since we are talking about electron, we can write Q as E. So Fm becomes BeV, and V is the velocity of electron. So basically, in this experiment, we had seen that they have assumed the electrical force and the magnetic force as equal. If Fe is equal to Fm, so capital E equal to BV. From here we get the formula for velocity of electron as E by B. Now we, in this formula, we got the value of A, we got the value of T, and from the previous formula we get the value of V also. So in this formula we put the value of V. So what we get after putting the value of V here, one E is cancelled. That leaves the value of Y as half of x square b square by m. Sorry, there is one E. So we get this ratio E by m. What is E by m now? E by m equal to 2y by x square b square. Yes. So the values of x and y can be measured in the experimental setup. The value of E and B are known. From there we get the ratio of charge to mass ratio of electron, which is calculated as 1.75880 into 10 to the power 11 coulomb per kg. So this is the charge to mass ratio of an electron. Now after getting the charge to mass ratio of electron, we need to find out the charge and mass separately. The charge and mass of electron was separately found out by Millikan oil drop experiment. This experiment was performed by R.A. Millikan, who considered the oil drop as a charged particle between an anode and an cathode, which was charged by X-rays, and the stationary oil drop was observed with a microscope, from which the charge of electron was calculated. The setup for Millikan oil drop experiment was like this. There was an atomizer with some source of oil. Some oil droplets were sprayed into the chamber. This screen was cathode, and below it there was another electrode, that is the anode, and in this space there was a microscope which viewed the oil drop, and there was one X-ray source. Which generated X-ray into this chamber, and this chamber was filled with gas. Let's consider H2. So what we had studied in the cathode ray experiment, that H2 can generate 2H plus, 2H, so the gases will release electrons. Now From this atomizer, oil droplets were released into the chamber in the form of mist. Like now a single oil drop, if it passes through this hole and enters the chamber with the X-ray, the electrons generated from the gas in the presence of X-ray will ionize the oil drop. Now the ionized oil drop has two kinds of force acting on it. One is the electric force, which acts upwards. Since the anode is upwards, so the electric force will deflect the oil drop upwards towards the anode, and the downward force is the gravitational force. Now by very careful adjustments, the forces acting on the oil drop were balanced such that Fe equal to Fg. So now the oil drop becomes stationary. From this concept, we will calculate the mass and charge of electron. We will study this concept in the later part. Thank you.